Hey, welcome to The Explainer. Today, we're going to take something that looks like total mathematical chaos and turn it into something beautifully simple.
Okay, take a look at this. I mean, it just looks like a total jumble of symbols, right? But what if I told you there's a really simple, elegant answer hiding inside? Well, today, we're going to go on a little journey to find it by learning exactly how to simplify these linear expressions.
All right, so let's dive right in. The very first step to tidying this whole thing up is using a tool called expansion. And really, you can just think of it as, well, unpacking the problem. So what is expansion? It's basically the process of getting rid of those brackets. It's kind of like when you get a package and you unpack the box. It lets you see all the individual little pieces you have to work with. You lay everything out on the floor before you can start putting it all together. Now, the key that unlocks all of this is something called the distributive law. And here's a great way to think about it. Imagine you're a newspaper carrier. The term that's sitting outside the bracket, that's your newspaper. And you have to deliver it or, multiply it by every single house, every single term that's inside those brackets. You can't miss a single one. And this rule, it works no matter what's going on inside those brackets. It doesn't matter if you're adding, if you're subtracting. That term on the outside gets distributed to every single piece. You could have 2 terms, 3 terms, a dozen terms. Everybody gets that newspaper. Okay, theory's great, but let's actually put this into practice. Check this out. This one's kind of interesting because we've got brackets inside of other brackets. Now, don't let that intimidate you. The rule here is super simple. You always start with the innermost set first. Think of it like a Russian nesting doll. You work from the inside out. All right, first things first, we distribute that -5 across the inner bracket. So, -5 times 3, that gives us -15. Easy enough. But now, and this is the part you really gotta watch, -5 times -x, that becomes a positive 5x. A negative times a negative is a positive. Seriously, that little sign change is where so many people get tripped up, so keep a close eye on that. Okay, so we've unpacked the inner box. Now it's time to start sorting through the pieces we've laid out. And that brings us to our second amazing tool, grouping like terms. The best way to think about this, it's just like sorting laundry. You put all your shirts in one pile, all your socks in another. In algebra, it's the same idea. We're going to group all the terms that have this same variable, so all the x terms go together, and all the plain old numbers go together. We're just combining things that are alike to get rid of some of that clutter. So let's jump back to our problem. If you look inside the bracket now, you'll see we have an x and a 5x. Well, they're like terms, so we can just combine them. 1x plus 5x gives us 6x. See? Look how much cleaner and simpler that looks already. We're making real progress. And we are so close. We're on the final step. We just need to use that distributive law one more time. That 2 on the outside, we're going to multiply it by the 6x and by the -15. And what does that give us? Our beautiful, final, simplified answer, 12x minus 30. How cool is that? We went from that crazy initial mess all the way down to this clean, simple result. Okay, so we've gotten really good at taking these expressions apart, at unpacking them. But what about putting them back together? It's a great question, and this is where our next tool, factoring, comes into play. It's basically the art of working in reverse. Yeah. Factorization is literally the exact opposite of expansion. If expansion is unpacking the box, then factorization is looking for common items to neatly pack back into the box. All we're doing is finding what all the terms have in common and then pulling that common thing out to the front. And the absolute key to doing this right is finding what's called the greatest common factor. It sounds fancy, but all it means is you're looking for the biggest number, or maybe a variable, that can divide evenly into every single part of the expression. Let's take a look at an example, 15a plus 20b. So, step 1, what's the biggest number that goes into both 15 and 20? Well, that's 5. So 5 is our greatest common factor. Step 2. We're going to pull out that 5 and stick it outside a new set of brackets. And for the final step, we just write what's left over inside the brackets. So what's 15a divided by 5? That's 3a. And 20b divided by 5? That's 4b. And there you have it, 5 times 3a plus 4b. Simple as that. All right, so we've talked about expanding, grouping, and factoring. But you might be sitting there thinking, okay, cool, but why does any of this matter? What's the big picture? Why do I actually need to know how to tidy up these expressions? And that's a great question. The thing is, these skills are about so much more than just getting the right answer on a math test.
When you master expansion and factorization, what you're really learning is a fundamental skill: how to take a big, complex, messy problem and break it down into smaller, manageable parts. And that is the foundation for solving much bigger, more interesting challenges, not just in algebra, but in all kinds of fields like engineering, physics, even computer science.
So, you see, by learning to treat simplification as just a process of bringing order to chaos, you've actually picked up an incredibly powerful tool. You can now look at any messy-looking problem, whether it's in a math book or out in the real world, and you have a strategy for how to tackle it, one step at a time. You've learned how to turn chaos into clarity. So the only question left is, what complex idea are you going to simplify next?